So let's look at two more examples, and why don't you just turn your paper over and we'll do those on the back. Okay, we're trying to determine if this series converges or diverges. So again, going through the checklist, just to remind you, this is not a geometric series. If I found the limit of the nth term, I would get 0. So that gives me no results. For the integral test, if I modeled this with 1 over 3x squared plus 2, it's not easily integratable. So in that case, that leads us to the DCT, the direct comparison test, which is what obviously we're going to use in this video. Alright, so our first task is to figure out what it most closely resembles. And as I look at it, I'm thinking it most closely resembles 1 over 3n squared. So I always like to make myself a little note over here what it resembles, what I'm going to compare it to. Okay, so this one right here is actually a Convergent P Series. So just think of it as 1/3 being pulled out front. We do have a property series that says that we can do that. We can pull the 1/3 out front and we're left with 1 over n squared. And you may remember that because the power, the exponent, is greater than 1, this is going to be a Convergent P Series. So put yourself a little note over here that it's Convergent P Series. Alright, so now that we know that this is a Convergent P Series that I'm going to compare it to, if this converges, then we want this series over here to be the smaller one, because if it's smaller, less than this series right here, then it's also going to converge. So now we know how to, indicate which series A and which series is B. So A is the smaller one, so we want the given series right here to be smaller underneath B, the larger one here. Okay, so just make yourself a note here too. Okay, we're going to do term by term comparison. And I'm going to put a question mark up here. So we're hoping that when we evaluate these at different n values, that these terms will always be smaller than these right here, so that we can then say that this series converges. Okay, let's let n be 1. So the first term would be 1/5. If n is 2, that would be 14. If n is 3, 9, 27, 29. Okay, and it might be good to do a couple more, but I think I can kind of see that these terms are all going to be smaller than these. Okay, so are these terms less than or equal to the ones I generate with the same n values? So if n is 1, we get 1/3. If n is 2, we get 1/12. If n is 3, we get 1 over 27. So let's just look at the comparison. 1/5 is definitely less than 1/3. 1/14, a larger denominator, okay, is going to be smaller than 1/12. 1/29 is going to be smaller than 1/27. So these denominators here will always be bigger, meaning the value of the fractions will be smaller. So it looks like this one is going to work with that comparison. So I'm going to come up over here, okay, maybe, and say that therefore by the DCT the series converges. All right, we're going to take a look at one more example that's pretty straightforward as well. It just gives us practice in picking out identifying the the series that we're trying to compare it to. Okay, let's determine if this series converges or diverges. So let's pick out a resembling series that we know converges or diverges. So this series resembles this series right here, 1 over the square root of n. Okay, and we know that that's a P series with the power of 1/2. Okay, and that's smaller than 1, so it diverges. So this is a divergent P series. Okay, so let's establish of these two which one's A and which one's B, which one's smaller and which one's larger. Well, it's all depending upon what you compare it to. Since this is divergent, okay, we want this one to be the smaller one so that this series right here would be larger, and if it's larger than this divergent series, it also will diverge. So that's kind of the route we want to go. We want this one to be the smaller one, so that's going to be our A sub n. Let me go back and take off this series. I just really want to look at the term. Okay, and then we're going to compare them term by term. Question mark. Would every term of this series be smaller than this series right here? Okay, let's let n be 1. So we'll have 1. N be 2, 1 over square root of 2, etc. I think I'll generate one more. If n is 4, we're going to get a half. And that's just kind of easy to compare. Are all these terms less than or equal to the terms generated by these same n values? So 1 over... Okay, and notice right here that if n is 1, that we're going to get division by 0. So that tells me, as I'm looking at my paper here, I think I might have needed to put this as 2 in my original problem. So let me go back here and change this. Okay, let's say now this was our series right here. Okay, so I'm going to compare it to the Divergent P series, and I'm just going to start it at 2 instead of 1, because I should have noticed that if this is 1, I would be dividing by 0. So that was just a transfer error from my paper to here. I had a 2 on my paper. I just put it as a 1 because all the other ones were 1. All right, let's make that adjustment then. Okay, down here. Okay, if n is 2, then I wouldn't have had this term right here, and this would have been my first one, my second one, my third one. Okay, so now here we go. If n is 2, then we're going to have the square root of 2 minus 1. If n is 3, I'm going to have the square root of 3 minus 1. If n is 4, I'm going to have 1 over square root of course 2. 2 minus 1 is 1. Okay, yeah, this is a better comparison now. That was just a transfer error. Okay, easy enough to fix. All right, so 1 over the square root of 2 compared to 1 over the square root of 2 minus 1. Well, this will be a smaller denominator, which means that the value of the fraction will be bigger than 1 over the square root of 2. Likewise here, this denominator is smaller, which makes the value of this fraction larger than if it was just 1 over the square root of 3. And these last two that I can compare, clearly we can see one is going to be bigger than 1/2. And that pattern will continue. So it looks like we found the right comparison to discuss convergence, divergence of this series. So therefore, by DCT, the given series is going to diverge. Because it's smaller than, or excuse me, it's larger than an already divergent series. So by the DCT, the series is going to diverge. All right, so that was the DCT, yet another test to determine if a given series converges or diverges. Okay, so we have two more. We have the alternating series test and also the ratio test in upcoming videos. And no worries, once we get through all the tests, we're going to take some time to just kind of put them all together and look at series and kind of review which test would be the best.